I saw a geometry problem in a geometry book that told you to draw a triangle like this one. The base had to be 6 and the height had to be 5. So notice I drew this one 3 this way and 3 that way to make the total 6 as the base. And of course the height is this straight distance, which makes this peak point 0, 5. So this length is 5 and the bottom length is 6. So the next thing they ask you to do is to find this length over here, which is going to be the same as this over here because it's an isosceles triangle. Well, there's a couple of ways to do that. Probably the easiest way to do that is to think of this triangle here, this one, as a right triangle, and this distance is 3 and that distance is 5. So one way to do that problem is to use the Pythagorean theorem. So a leg squared plus another leg squared is equal to the hypotenuse squared. So I would do this right here. A squared plus b squared equals c squared. So one leg is 3, the other leg is 5, and we're finding the hypotenuse, which is c. 3 squared is 9, 5 squared is 25. You add them together, you get 34. You take the square root of both sides, you get the square root of 34. So this distance is the square root of 34 by using the Pythagorean theorem. So another way to do that is to use these endpoints, 0, 5, and -3, 0. Use those endpoints and do the distance formula. So this is the distance formula. And if you take these 2 points and you plug them in, this is x1, this is y1, this is x2, this is y2. If you plug those in down here, it's going to look like that. So I'm subtracting the 2 x's, -3 minus 0 in parentheses squared, and then the 2 y, 0 minus 5 squared. Well, this becomes this, and this becomes this. -3 squared is 9, -5 squared is 25. You add those together, you get the square root of 34. Notice this distance is the same as the distance that we got up here, so it works either way. In fact, the distance formula is a direct result of the Pythagorean theorem. See ya.